have log of something with base b plus log of something else with the same base, I can write them as one log and then multiply them together. So when I have log of x with base b and log of y with base b, notice that the bases are the same. I can rewrite this expression as one log and multiply the arguments together with the same base. But if they are getting subtracted by each other, I can rewrite it as log of x divided by y base b. Again, bases are the same. And if I have some number, some constant, getting multiplied by the log I can rewrite this as log of x to the a base b. So this coefficient here moved to here as the exponent of the argument.
Okay, so let's go ahead and look at this first example. Notice they already have the same base, so I could apply the log properties to it, but let's just go ahead and do it like we didn't know that for a second. So what this is telling me is that 2 to what power is 4, and we know that that's 2, okay? And then what this is telling me is 2 to what power would be 8, which is 3. So 2 plus 3 would be 5 if we did not want to apply the log properties to it. So just remember this 5. Alright, but if we did want to apply the log properties to it, notice it's this one because we have the same base and addition's happening. So what we're going to do with the insides of the logs is multiply them. So then we're just going to write it with the same base once, and then we're going to multiply what they're carrying. So 8 times 4 is 32. Okay, so we applied the log properties to it. Now what this is saying is 2 to what power is 32, and we know that that's 5, right? Okay, so you end up getting the same answer. Alright, so here's another example. Notice they have the same base. So, but you know what? We don't know these log properties for a second. Let's just do it. This is saying is 2 to what power is 32, which would be 5. And what this is saying is 2 to what power is 16, which is 4. So 5 minus 4 would be 1. If we wanted to do this without the log properties. So now if we want to do it with the log properties, notice it's the second one, subtraction's happening, we have the same base. So what we're going to do with the insides of the logs is divide them, starting from the first one. So I'm going to get log base 2, starting from the first, so it's 32 divided by 16. So that would be the log of 2. 32 divided by 16, that's 2. Alright. What this is saying is 2 to what power is itself? What 2 to what power is 2, which is 1. Okay, so we end up getting the same answer again. So let's just do an example with the power law, and then get going on some harder examples. Alright, so here's an example having to do with this third log property, but let's act like we don't know that for a second. So, now we have an exponent, right? So let's just apply the exponent. 4 squared is 16. So then we'll get log of 2, 16. And what this is saying is 2 to what power would give me 16, which is 4. So then we get 4. But let's say we want to incorporate this third log property to see if we get 4 again. Alrighty, so what this third log property is telling us is if we have an exponent, we could bring it back and multiply it. So let's go ahead and bring this 2 back and multiply it. So then we get log base 2 of 4. Alright, so then we get 2 times, what this is saying is 2 to what power is 4, which is 2. So 2 times 2 would be 4. Alright, so I just want to do some simple examples having to do with these properties. Alright, so those examples I did didn't quite prove these properties here, but I hope they shed some light and made you feel like you could work with them. So we're going to go ahead and use these log properties to solve equations with logs later. So they'll come in handy. And what we're going to do today is just going to go ahead and expand and condense expressions with logs with what I showed you today. And we're going to assume that all arguments behave in a way that they are bigger than 0. So when you look at a log, there's like 3 parts to it. There's the base, there's the inside of the log, and then there's the exponent. So when we're talking about the argument, we're just talking about the piece that's inside the log. So the argument here would be 8. Alright, so we're just going to go ahead and start on some examples. Alright, so the directions here are to expand this thing out. So inside the parentheses, I just see a bunch of multiplications. I could stick to steps that we follow, but you know, pretty much you just want to go ahead and apply the log properties from left to right. If you see any roots or radicals, you want to rewrite that as exponents. And then at the end, if there's any exponents left over, you want to just go ahead and bring that back. So I just see a bunch of multiplication happening, so it's this one. And we always have the same base. So I'm going to write an addition sign in between these terms and these terms here. So it's going to be log base 2 of 8 plus log base 2 of y cubed plus log base 2 of x. Okay? So right here we notice this could be simplified. This is like saying 2 to what power is 8, which happens to be 3. So this is just a 3 here. And then, like I said, if there's any exponents left over, we just want to go ahead and bring that back, because that's just simplifying further. So plus 3 log 2 of y plus, and there's nothing really that we could do here. So this would be the final answer. We were given this expression here, and then if we were to expand it, it would look like this. And you could always work backwards, which is what we're going to do later. But let's go ahead and do some more examples with expanding. Alright, so second example here. So we're going to go ahead and expand this thing out. That's what the directions are. So I notice multiplication happening up on top on the numerator. So that's going to be the addition, right? And then this division is going to cause subtraction. The only thing I suggest is that when you, this division, I would just suggest opening up a parenthesis for that negative to distribute through. So you'll see what I'm talking about. It won't happen in this case, but just be careful with the division. Alright, so we're going to get log base 8 of 64. This multiplication will be an addition. X. Okay, so this division now is going to be a subtraction, but I always like to open up a parenthesis because I don't know if, you know, and then log base 8 of y squared. Okay, if I had another term here, if it was positive, that negative would have to distribute to it. So I see a lot of common mistakes being made there. Okay, this could be simplified. This is like saying 8 to what power is 64, which is just 2. Nothing to do here. So here's the minus, and then we can bring back exponents, right? So we just bring the 2 back. So it'll be 2 log 8 of y, and that's as much as we could expand this thing. So that would be it. Alrighty, so why don't you guys go ahead and give this a shot, pause the video and whatnot, and then I'll go over it with you. Okay, so assuming you gave that a shot, I just see 2 terms here, this x cubed and whatever's inside the parentheses squared. They're being multiplied, so we're going to use the first property, and the directions are to expand, right? So, and you know when you expand you always have the same base, so you don't have to worry about that. And we're just going to use the log properties from left to right, and if we see any exponents at the end, we'll bring them back. So this will be log 7 of x cubed. This multiplication indicates addition. plus 1 squared. Okay, we look here, here's the base, here's what's inside the log, an exponent, so it has to come back. Alright, so here is a base, here's the inside, there, that's an exponent, right? So we got to bring it back. Plus 2 log of 7 y plus 1. So we are done, but I just see most students think that we could further maybe simplify something like this in here with the y plus 1. So there's no property or law that says that you could distribute the law into the, the inside of a log. So this is as far as you could go. And yeah, there's no laws having to do with the argument of a log. So this would be the final answer. Okay, so why don't you guys go ahead and give this a shot, and then we'll go over it together. So this radical could be a bit intimidating right now, and the directions are to expand. So when we're expanding, I didn't really want to make a list of things for us to follow. We just wanted to use the log properties from left to right. And if we see any square roots or any rads, anything like that, we want to make those as powers. And at the end, we just want to bring any exponents back that are left over. So I'm just going to rewrite this square root as a power right now. A square root is a 1/2 power. So instead of rewriting all this again, let me just rewrite that square root as a 1/2 power. So what it's looking like right now is that 2 is the base, this is the argument, or what's inside, and that's the exponent. And by this third property here, I know that I can bring back the exponent and multiply it. So let's just go ahead and bring that 1/2 back. All the way to the front, so we get 1/2. Now, I'm just going to open up a parenthesis because all this stuff is going to get expanded, so this 1/2 has to distribute into everything. So there's nothing to do on top. Okay, this division implies subtraction. Just go ahead and open up that parenthesis whenever that happens. You'll see why right now. On the bottom, multiplication is happening, so that's the first property. Log base 2 of y cubed. So multiplication is addition. Log base 2 of z to the 5th. And there's another parenthesis. I was just closing up the subtraction over here. But, that's the actual parenthesis to close up everything. Okay, so this 1/2 is still outside. With this, we can just bring the exponent back. Okay, now this subtraction has to get distributed into both of these terms here. And why don't we just bring the exponent back in the mean while we're doing that? So it'll be a -3 log base 2 of y. Now a negative times a positive would be a negative again. And let's bring back that exponent 5. Okay, so let's close this up. Okay, so the only thing left to do now is just multiply everything that's there by a 1/2. Can't forget about that, right? And then we would be done. So 1/2 times a 2 is just 1, right? So then we get log base 2 of x minus a 1/2 times 3 is 3/2. Okay, and then 1/2 times a -5 is a -5/2. Okay, so we've expanded this thing out as much as we can.